Good evening. So I'm going to demonstrate my ERD using Chen's database notation. So in Chen's database notation, we basically use three shapes. There are more shapes, but basically we use three shapes, though these shapes may mean something different. For example, you have the diamond shape, which represents the relationship between the entities. For example, this one, it describes the relationship between the interventions entity and the geographic location entity. So we have the rectangle, and this represents the entity. Then the ovals, which represent the attributes in the entity. Then you have these lines connecting to the entity. These connect like this, show that these attributes are connected to this entity. So we have different kinds of ovals. We have ovals, for example this one, which has the attribute name underlined. This means that this is the primary key in this entity. Then we have these other normal ovals without any special markings. This means that these are the attributes these are all attributes, but this is the primary key, and these are the other attributes in the geographic location entity. So moving on to the interventions, we have the same thing, but then here we have this oval, which has broken boundaries or broken lines around the boundaries. This means that this is a foreign key, or it's a derived attribute, which means that this is a primary key in another entity. As you can see, we have here a location ID as a foreign key, and here we have the location ID as the primary key. Then moving on to, we have this oval shape as well. As you can see, it has two layers. This means that this is a multi-valued attribute. For example, this one has two more attributes, which is the first name and the last name of the patient, meaning that this is a multi-valued attribute. If you see any of these, this means that it's a multi-valued attribute. Then as you can see, we have the 1 and the n. The 1 means 1 and the n means many. So this is used to define the relationship between the entities. So I think now I can move on to the relationship between these different entities on my screen, okay, so let's start with the geographic location. The geographical location has different entities related to it. For example, the geographic location, it's in a relationship with the interventions, with the health facility, and with the epidemiological data. So describing the relationship between these entities, we see that the geographic location is in a one-to-many relationship with the interventions. This means that many interventions can be collected from one geographical location. Then the geographic location is in a one-to-many relationship with the epidemiological data, and this means that multiple epidemiological data can be collected from one geographic location. And lastly, in the geographic location, it's in a one-to-many relationship with the health facilities, and this means that one geographic location can have multiple health facilities. Moving on to the next entity, which is the health facility. The health facility is in a one-to-many relationship with the visit records, meaning that one health facility can have multiple visit records. Then still the same health facility is in a one-to-many relationship with the facility type, and this means that the one health facility can have multiple facility types. Then the health facility, again, it's in a one-to-many relationship with the resources, meaning that one health facility can receive multiple resources. Then the health facility is in a one-to-many relationship. As you can see, it's 1 to n, which means it is in a one-to-many relationship with the supply chain, which means one health facility can manage multiple supplies. Then health facilities in a one-to-many relationship with the malaria cases, as you can see, and this means that one health facility can have multiple malaria cases. That's it for the health facilities. Then we move on to the patient data. Patient data is in a one-to-many relationship with laboratory test, meaning that one patient can have multiple laboratory tests, and still the patient data is in a one-to-many relationship with the visit records, meaning that one patient can have multiple visitors. It's also, patient data is also in a many-to-one relationship with the referral, meaning that many patients can have the same referral. And moving on to the next table, which is malaria cases. Malaria cases is in a one-to-many relationship with patient data, meaning that one malaria case can be, or many patients can have the same malaria case, which is a many-to-one relationship or a one-to-many relationship, respectively. So moving on to still malaria cases has a many-to-one relationship with the treatment table, meaning that many malaria cases can have the same treatment. Still malaria cases is in a many-to-one relationship with the treatment outcomes, meaning that many malaria cases can have the same treatment outcomes. Then malaria cases is in a many-to-one relationship with the malaria type, meaning that many malaria cases can be of the same type. Moving on to the next entity, which is the user. User also has different relationships with other entities. First of all, it's in a many-to-one relationship with the training table, meaning that many users can undergo the same training. User table is also in a one-to-many relationship with user role, which means one user can handle multiple user roles. User still is in a one-to-many relationship with the system log, meaning that one user can handle multiple system logs. Let me see if there is any entity I've left out. So the supply chain and the resources. A supply chain is in a one-to-many relationship with the resources, meaning that many resources are handled in one supply, or one supply can manage many resources. So I think that's it for the relationship. Let's move on to the SQL code. So for the SQL code, I've created this database for demonstration. So I wrote my SQL code here in the VS Code. So I'll just copy it. and then create a query. I'll create an SQL. So for this SQL, we shall have, I'll paste my SQL script here, since I already wrote it in VS Code. So here we shall link it to the database. We shall use this command, use then the database name, which is coursework, and then with a semicolon. So when you come to this, as you can see, we have used the create table command to create a table called geographical location. As you can see, we have the location ID as the primary key, and this is an integer. We have different attributes in it. Moving on, we created the facility type table, still using the same command, which is create table, having the facility ID, the facility type ID as the primary key, and this is an integer. So yeah, then we created the health facility table. We have the facility ID as the primary key. We have two foreign keys in this case, which is the location ID, which refers to the geographic location, and we have the facility type ID as another foreign key, which refers to the facility type. So what I did here basically, I created tables without foreign keys first, so that when I run my table, I won't experience any errors. So here, when I created this table, I created this before any other tables because it has the location ID as a foreign key and the facility ID as a foreign key, which we have already created the tables up here. Then so I did this in a chronological order, I did this in a chronological order, creating tables whose foreign keys will be needed first before I create the table in which I'm going to put the foreign key. As you can look here, we have created the supply chain table. It has the resource ID as a foreign key, and we have already created the resource table, which has the resource ID as its primary key. So this applies to the rest of the tables that I've created. As you can see. So when we execute this script of ours, we have already linked it to the database in which it should be running. So when we run the script, when we execute the script, it will run, and then these are the logs down here, and it shows that it's all successful with these ticks here, the green ticks. So we come here and refresh the database. So when you go to the tables, we should be able to see the tables here. So for example, we have the epidemiological data table. So in the epidemiological data table, we have the attributes. As you can see, we have the different attributes here, and we can insert the data here. For example, let me say the date ID, the location, let me say Masaka, location ID, then recorded date, let me say we can enter a random date, let me say 12th of December 2024, then case per 1,000 people, let me say put a random number, temperature, let me say 65, let me say 22, then rainfall, let me say 129, added by, then let me add a random name, then update date, enter the date as well. So as you can see, our tables have been created. The malaria cases table, it's also here. Yes, so I think basically that's it. Thank you.